Hello everyone, welcome back to our last lecture of chapter 19, Maintaining Air Quality. Now this video series has a total of 3 lectures. The first lecture video focused on the percentage composition of gases in clean and dry air. The second lecture video focused on atmospheric pollutants and acid rain. And finally, we are now at the final lecture video for this chapter, which will focus on a topic that's very familiar to all of us, which is global warming and climate change. Now, we have heard so much about global warming, climate change, and the role that greenhouse gases like CO2 play in this. We have heard so much about carbon dioxide being a major contributor to global warming and climate change. We have heard about carbon dioxide increasing tremendously over the past 100 years in our atmosphere. But is CO2, is a greenhouse gas really so bad? Can we survive without any CO2 at all? Now, the idea is without greenhouse gases like CO2 on Earth, our Earth will be too cold to live in. Okay, CO2 is actually quite useful because it helps to trap some of the heat in the form of infrared radiation on the Earth's surface. And this allows the surface temperature of the Earth to be maintained at a healthy temperature that is not too hot and not too cold to support life. Now, this greenhouse effect is called a natural greenhouse effect. This is naturally occurring and is good, is desirable. Without this natural greenhouse effect, the Earth's surface will be too cold to support life. It's estimated that the Earth's surface temperature would drop to minus 18 degrees Celsius if there was no CO2 at all. Since CO2 is so good, why is it then now a problem? It's now a problem because the levels of CO2 in our atmosphere have increased significantly over the past 150 years or so. It has increased so much that now the trapping of the heat has become so significant that it has changed climate patterns across the world. And this change in climate pattern is what we commonly call climate change. So, CO2 is not necessarily a bad thing. The key thing is to control the level of CO2 at a level whereby it is desirable, it is good. And how do we control the level of CO2 in our atmosphere? The level of carbon dioxide in our atmosphere is controlled by the carbon cycle. So, shown here in the picture is the carbon cycle. It shows you the pathway taken by carbon dioxide. Some pathways involve carbon dioxide being released to the atmosphere. Some pathways involve carbon dioxide taken in from the atmosphere. So now let's take a look at this picture at the very bottom of page 5 of the notes. Pathways like photosynthesis, ocean uptake. These two pathways take in CO2 from the atmosphere. So in this aspect, they actually take in the carbon dioxide from the atmosphere and help to lower the level of CO2 in our atmosphere. Now, photosynthesis should be a process that all of us are familiar with. This is the process by which plants absorb and take in CO2 in the presence of sunlight to make food. Now, this is a very important process because this is one of the very few processes which take in CO2 from our atmosphere and help to lower the level of CO2. Now, besides plants photosynthesizing, the ocean is also a very major process that actually takes in CO2 from the atmosphere. Because in the ocean, we have algae. Some algae actually photosynthesize. Besides algae in the ocean water naturally also takes up the CO2 from our atmosphere. So ocean uptake and photosynthesis are the two important processes which take in CO2. Now, there are some other process which actually release CO2. They do the reverse. So, for instance, we have combustion of fossil fuels. Combustion of fossil fuels, as we have learned in our chapter on alkanes and alkenes, that when we burn the fossil fuels, we actually release carbon dioxide gas. And this carbon dioxide gas is released into the atmosphere. Respiration. Whenever humans, animals, living things in general release energy from glucose from our digested food, we also release carbon dioxide in the process. All right. So respiration is a natural process which releases carbon dioxide to the atmosphere. And finally, When living things die and decay and decompose, that also releases carbon dioxide to the atmosphere. So basically, we have some processes that take in CO2, such as photosynthesis and ocean uptake, and some processes that release or give out or increase the CO2 in the atmosphere. Okay, into the atmosphere, sorry. Okay, now you must be able to label the processes if this diagram were to be given to you without labels. You should be able to recognize which arrows are photosynthesis, which arrows may represent combustion of fossil fuels. Now, on the next page, I've given you some details about the processes that take in CO2, such as photosynthesis, ocean uptake. Okay, you need not learn the equation for photosynthesis. I've put it there for your reading pleasure and also your enrichment. Now, ocean uptake is an important process that many students sometimes forget. Okay, oceans are very, very important places where carbon dioxide can be stored and taken in. So, oceans help to reduce the amount of carbon dioxide in the atmosphere. Now, relevant to this point about oceans, because now we have increasing CO2 levels in the atmosphere, more CO2 will dissolve in the ocean water. Now, this is not necessarily always a good thing. If you have watched the second lecture about acid rain, sulfur dioxide, nitrogen dioxide, they are acidic oxides as they are non-metal oxides. Similarly, carbon is also a non-metal. So if carbon is a non-metal, CO2 is also a non-metal oxide. So CO2 is actually also acidic. Okay, so CO2 is an acidic oxide. Since it's an acidic oxide, as it dissolves in the ocean, it will lower the pH of the ocean. So if you recall, lowering the pH means it's more acidic. So what happens with increasing CO2 levels is that it becomes more and more acidic in the ocean. Now, this is not necessarily a good thing because your shellfish, such as scallops, oysters, abalones, all right, their shells and skeletons are actually made up of calcium carbonate. So again, you should recognize the chemical names. Calcium carbonate. Calcium carbonate is an example of a carbonate. So if the oceans were to become more acidic and have a lower pH, what happens to the shells? The shells and the skeletons, which are made of calcium carbonate, will react with the acid. So they will be corroded over time. It is similar to how acid rain actually corrodes limestone structures. It's the same kind of concept. It involves the reaction between acidic water and carbonates. So the shells and skeletons will be corroded over time, and the corrosion would cause the shells and skeletons to be weakened. And this is a growing problem. You see that the yield of oyster farming has slowly decreased with time. And the main reason is because of increasing temperature in the water as well as increasing acidity in the water. So this increased CO2 dissolving into the ocean may not necessarily be a good thing. And hence the importance of the carbon cycle. Some processes taking in CO2, some processes giving out CO2. These must be kept in balance so that the amount of CO2 inside our atmosphere is kept at a healthy, balanced level. Okay? Now, there are some processes that release CO2 as mentioned, such as respiration. We release CO2 in the air that we breathe out, and this CO2 came from respiration, which is the process of converting glucose into carbon dioxide and water and releasing a lot of energy in the process. Okay? So besides respiration, combustion. Combustion of fossil fuels such as coal, petrol, natural gas, they release a lot of carbon dioxide gas. Okay? So who releases these greenhouse gases? Combustion of fossil fuels occurs in cars, factories, power plants. Okay, these are all sources of carbon dioxide from combustion. Finally, when living things die, the bodies decay and are decomposed by bacteria. So when bacteria break down the organic compounds inside living things, this will release carbon dioxide gas in the process, which is released into the atmosphere. So respiration, combustion of fossil fuels, and decay actually help to release CO2 and increase the CO2 in the atmosphere. Now, of these three processes which release CO2, of course, the most significant man-made source is combustion. Combustion of fossil fuels is a man-made process. Humans are driving this process through industry, through vehicles. If you look at the next page, this is the graph of global CO2 concentration in our atmosphere. You can quite clearly see that the CO2 levels at the start until about 1850. So this is about 1850. This is the year 50. So up until 1850, the global CO2 levels in the atmosphere have remained constant, low. However, after 1850, the global CO2 atmospheric concentration has increased dramatically. It has increased so steeply, you can clearly see the gradient, the level of increase. It's staggering, it's really drastic. So why is it so drastic? There is only one reason, and this is a man-made cause. It is industrial development. All right? The development of industries, factories, power plants, cars, and all this involves combustion of fossil fuels. Because of the widespread combustion of fossil fuels in engines, in power plants, that resulted in an increase, a dramatic, steep increase in the amount of CO2 in the world. Okay? And this is also summarized below. Increased rate of CO2 production following the Industrial Revolution, as well as decreased CO2 removal because of deforestation. So if you recall, our plants and trees, they help to carry out photosynthesis to take in CO2 from the atmosphere. But what we have also done is to make way for roads, for modern cities, for factories. We have cut down the forests. In cutting down the forests, we are removing trees, which help to remove CO2. And hence, we are producing more CO2 and removing less CO2 as a result. This causes an imbalance in the carbon cycle. And because of the imbalance in the carbon cycle, now we are looking at enhanced greenhouse effect due to increased CO2 in the world. Okay? Now, what is the impact of this enhanced greenhouse effect? Obviously, climate change. We have heard so much about climate change, but what are the impacts specifically? So the impacts of increased global warming and climate change include extreme weather conditions, stronger typhoons, stronger storms, or prolonged drought in certain places. So in certain places, there might be so much rainfall. In certain other places of the world, there may be no rain for months. And this could really affect us. So shown here are the QR codes, okay, to several articles, including a heat wave in India. Okay, so the heat waves in India can be really severe right now. The highest temperature reached could be something like 45, 47 degrees Celsius. That's really, really high. You are also looking at stronger hurricanes and typhoons, very strong storms with very powerful winds, drought in California. So no rainfall in California in the USA. If there's no rainfall, that increases the risk of forest fires. Because it's so dry, the forest may just catch fire and nothing will put the fire out. In addition, because it's so dry, there could be increased desertification. Desertification means the desert, the sandy desert, grows in area. The desert becomes bigger with time, it spreads. It can spread because there is no rainfall. As a result of the lack of rain, the deserts will start to grow in area. And finally, perhaps more importantly for Singapore, is the melting of the ice caps at the north and south pole of the world. You might think Singapore is so near the equator, why will we be affected by the melting of ice caps? The truth is, when the ice caps melt, that increases the sea level. The sea level doesn't just stop at the North Pole or South Pole. The sea levels will spread and rise all around the world. The seawater has to go somewhere. So how will this affect Singapore more? Singapore is an island country. All of us have learned that from young. Since we are an island country, we are surrounded on all sides by the sea. So any sea level rise will affect Singapore disproportionately. It will cause coastal areas to be more prone to flooding. And because of this, you see that the Singapore government over the past 5 to 6 years have made considerable efforts to actually protect our coastlines from erosion, protect our coastlines from flooding. Okay, some of these efforts you need to be aware. So I will highly encourage us to scan these QR codes to actually read through some of these articles, which could also be useful contextual knowledge for you when you do other subjects like geography or English language. All right. And finally, before we end off this lecture series, there is a reason why we end the chemistry curriculum with this chapter. We are ending the chemistry curriculum with this chapter because I really want all of us to think about chemistry as a subject. Chemistry as a subject is not just an academic subject, okay? It's not just for exams. Ultimately, you are learning chemistry because chemicals are all around us, right? Water is a chemical, CO2 is a chemical. There are good chemicals, there are also harmful chemicals. Perhaps what's important is not about whether the chemicals are good or harmful. What's more important is, do we know how to use these chemicals in a way that is good for everyone? Okay, so I hope as we end off this chapter with pollution, climate change, all of us will start to think about our lifestyles. How can we change our lifestyles to become more sustainable? How can we use our chemistry knowledge to lead more sustainable lives? And hopefully, this will spark some inspiration for us to use chemistry for good. All right, and this really concludes our three-part lecture series on maintaining air quality. Thank you very much.